Welcome to the Authority Podcast, Plumbing and Mechanical. When talking about the built environment, we would do well to remember, we shape our buildings, and afterwards, our buildings shape us. Therefore, on each episode, we'll discuss the latest trends from IAPMO in plumbing and mechanical safety, sustainability, and resiliency. Join me, your host, Christoph Lohr, and together we'll explore the ways we can make our buildings shape us for the better. And welcome back to the Authority Podcast, Plumbing Mechanical. On this episode, we're going to be talking about structural and behavioral water waste. And I'm very excited to have Mr. Jim Lutz, professional engineer and retired researcher, joining me on this episode. Jim, thank you so much for being part of this.
Oh, it's a pleasure joining you. Pleasure
Excellent.
to talk about stuff I know.
I was going to say, it's a pleasure to learn from you. I'm really excited to have you on here because, frankly, for me, this is a little bit of being in session with Mr. Jim Lutz and learning from you. And so I'm super excited to do this and then to share what to share your knowledge with our listeners as well. So before we dive into kind of talking about specifically the study on behavioral and structural water waste, do you want to tell our listeners a little bit about yourself?
Yeah, I was a researcher at Lawrence Berkeley National Lab for a couple dozen years and retired about 10 years ago. Started out there doing the cost-benefit analysis for water heater standards for the Department of Energy, and that got me into hot water. And I've been in hot water ever since. That's a bad pun. But from there, it's not just the water heater efficiency, and they were worried about energy efficiency. It's also what the water heater is connected to, the plumbing, how the hot water is distributed, how it's used. And when you start talking water heaters, you tie into water, so you get water efficiency, and it's the whole system got a lot more complicated once I dug into it, and I was able to get a bunch of other projects, one of which we're talking about here, and also through that work, I got active in ASHRAE, and I've been on the ASHRAE Surface Water Heating Technical Committee and was the chair of water heater efficiency test methods standard that ASHRAE wrote, which is pretty much what's adopted by the Department of Energy for the uniform energy factor now. So
Excellent. And then, Jim, for our listeners, can you tell them a little bit about what Ernest Orlando Lawrence Berkeley National Laboratory is? Some of them might not be familiar with the national laboratory system in the U.S.
Yeah, it started back actually before World War II. Lawrence was a physics researcher at UC Berkeley, and so the lab's right up the hill from UC. It's they did a lot of research on radiation. I think that's where plutonium was first made. They've gotten into all sorts of things beyond physics. They still have, accelerators up there. They're doing that. They do astrophysics. They do a lot of fancy materials. They do supercomputers and an energy efficiency section on buildings, and that's where I got in.
So definitely an official laboratory that has a long history of impacting the U.S. That's really amazing.
Right.
Well, so and your role there, you were in the energy analysis department.
Yeah, and that was. There were people in that department working on the electric grid and analyzing that and trying to figure out what to do it. There's people in there doing building modeling, simulation, indoor air quality, testing lab simulation, Windows researchers there, I was with the appliance efficiency standards part originally, and we were doing the basically the cost benefit for the efficient energy efficiency standards that the U.S. Department of Energy puts on appliances. So that's what, and I got on there and stepped into water heaters. And that's how I got into it.
That's awesome. Now, from water heaters, you ended up looking at the plumbing system, specifically the hot water
Right,
system. And
right.
and there were two studies that, well, I guess a study that was done. And I'm going to share screen here. So let me see if I can get this up and running. So there's two of them for our listeners. We'll put the links to each of these studies in the podcast description. But for our audio video um, participants, you're going to be able to see these. So this is one. This is the one that I first found, which was released in September 2011, which is a water and energy wasted during residential shower vents, finding from a pilot field study of hot water distribution systems. And there was a subsequent one. You sent me this one. This, I guess, was the follow up from in June of 2014 that was reducing waste in residential hot water distribution systems.
Yeah.
And it's kind of the same topic, just a slightly different
Well,
studies.
it's actually the same study, just
Okay.
an earlier version and a final version. Um, I got an opportunity to take early retirement before, we'd done all the analysis on the data. So these are unfortunately early results and not as thorough and in depth as I would have liked, but they are what they
But
are, and they
well,
do
but a good
reveal good stuff.
yeah. And I was going to say that what it reveals is some scientific evidence for structural and behavioral water waste. One of the questions I got for you, Jim, is what kind of discussions or when you were presenting this research, you know, I mean, obviously you're talking a lot about energy, and there's this whole water energy nexus. But in terms of water conservation, do you think this is a growing hot button item in the scientific community of right sizing water systems to help address water conservation? Again, it's not the only thing. I'm not saying it's a silver
It's
bullet,
definitely
but a
not the
contributing
only thing.
factor.
It is a contributing factor, and um, the other thing is because of the structural waste in the showers that I was pointing out, it turns out that low flow shower heads probably haven't been doing as much water conservation as you would expect. Because if you have a low flow shower head, you still got to get rid of all that water in the pipe. A low flow shower head doesn't save you anything on all that structural waste. It only gives you water conservation during the actual shower itself. So that's a so on the water utilities, they've pretty much given up on shower low flow shower heads as water saving, as water conserving. But I think it's actually hidden because of the structural waste sort of hides how much savings the shower head has. I mean, during the shower, they're definitely using less hot water, less total water. So there are savings there. But the structural waste built into it means just swapping out a shower head isn't going to give you the water conservation you would like. So this has been, well, many of your listeners will know Gary Klein.
Hmm.
This is definitely enforced and informed a lot of his thinking on this, and put some numbers on what had already been talking about. So when you talk about the efficiency of a hot water system, you don't want to talk about just the efficiency of the water heater. You got to talk about the plumbing system and all that. It's also, I think, supported the pipe sizing work that Dan Cole and those folks have done. That's now in an Appendix M, if I'm correct.
Yep, of the UPC. That's very true, Jim. Yes, and I think you're totally right that between Gary and Dan and Tojo Magomi and Steve Buckberger from the University of Cincinnati and um, I think Tim Wolf and the rest of the team there, that was the water conservation and energy conservation of this was a large part of that effort, and we stand and researching this.
Right. So that is but that is based on existing systems. So those pipe sizings, have the structural and waste and behavioral waste built into them. So if you did your plumbing system, if you put where you're going to use the hot water really close to the water heater, you wouldn't need as long a pipe, so you could make them skinnier.
Depending on pressure drop and everything else, yeah. Usually, it's with the calculations we're using. For like longest length, I think that typically for a home, the PSI per 100 feet isn't going to make too much of a difference from one size to the other on that alone, but the simultaneous of usage will.
Okay.
And that's ultimately the data that was analyzed for the water demand calculator was based on how often fixtures turned on and how frequently those ones were on simultaneously.
Right.
And so that's where you get that closer to alignment. You have like a factor of 2x for safety factor with the water demand calculator, as what Gary Klein found out when the water demand calculator, he presented his work to the state of California to get the water demand calculator adopted there. When you look at the Hunter's curve, it's like 20x, depending on your building time. We knew it was grossly oversized because it's congested use. The water demand calculator was done with no computers in 1940, assuming every building kind of worked like a sports stadium at halftime, which was better than assuming 100% flow. Everything on at the same time,
right,
which was what it was kind of before. So, but yeah, I think this is where the data on I think structural water savings, it's interesting. I think there's some people have seen it, others haven't. I'm aware that I think there was an IGC, I'm trying to remember what it was, but there was an IGC created for a product that tries to control for behavioral water waste in showers. You kind of pull a lever. And so that's where I first became aware of it. And started doing digging several years ago. And I think for you, it must be really interesting to see this work that you've done now coming back to sort of fruition in industry.
It takes a
probably
while.
gets a good, but let's give you a good feeling. What else was done with the research once you were done? Was there like a peer review process? Was it presented at ASHRAE conferences? Was it
I
in
think
academic
I did
journals?
presented at ASHRAE a couple times. It led to more research at the Energy Commission, work that Gary and Yonda and I did on trying to characterize this. I think it definitely led to better understanding of the importance of making your hot water system as compact as possible, which is something that plumbing and plumbers don't really have control over. But you got to talk to the architects and say, no, don't put the water heater in the garage over here and the kitchen over here. What are you doing that for? All you're going to do is have unhappy consumers. Put them closer together.
Yeah. And then there's energy and water savings involved. Let me ask this.
Right.
Let me ask you this, Jim. When it came to the work, so a national laboratory. When I saw the original report, the one from 2011, it said that the work was sponsored by the Department of Water Resources, and that it was supported by the U.S. Department of Energy. So these are government studies in essence.
And funded by the California Energy Commission as well.
And last word, what would you say to those that think that structural water waste or eliminating structural water waste through right sizing of piping systems isn't a viable means of trying to reduce water? What advice would you give those that are skeptical of structural water waste? What would you say to them?
I would say, do you remember that time you got into a shower and had to wait 2 minutes for hot water to get there?
Yeah.
Everybody's experienced it, hopefully not in your own home, but, everybody's seen it. Everybody's felt it. So I don't see how anybody can argue with it.
Gotcha. And you think there's a reason to go towards reducing structural water waste and behavioral water waste in the U.S. to try to help promote conservation?
Of not only energy, but also water. Yes. And unfortunately, the structural waste is literally built into the building. When the building is first built and plumbed, that's when the decisions are made on how long those pipes have to be and what size they are. And it's going to be in your house, in the building for 50, 100 years. So unfortunately, it's the sort of thing that's really hard to fix after the fact and really easy to fix before.
Yeah.
So think about it when you're designing a house. And, Christoph, I don't know how much influence you have over or connection you have to architects and designers, but when you're designing a building, cluster your hot water uses close to your water heater. Then you can use the short pipes, and then you can make them skinny. So
Excellent.
that's
Well,
where I'd leave it.
I love it, Jim. Well, on behalf of the Authority Podcast, Plumbing, Mechanical, and IAPMO, I want to say thank you for joining me on this episode. And hope at some point maybe we'll have you on again to kind of continue the conversation.
Well, if anybody is going to do this sort of research, I'd be quite willing to help them.
Excellent.
Point
Excellent.
out things not to do.
I love it, Jim. Thank you so much. Appreciate it.
Sure thing. Good talking to you.
Thanks for joining us on this week's episode of the Authority Podcast, Plumbing and Mechanical. Love this episode of the podcast? Head over to iTunes to subscribe, rate, and leave a review. Please follow us on Twitter @AuthorityPM, on Instagram @TheAuthorityPodcast, or email us at iapmo@iapmo.org. Join us next time for another episode of the Authority Podcast, Plumbing and Mechanical. In the meantime, let's work together to make our buildings more resilient and shape us for the better.